Hello, I'm Dr. Priya Hasan, and welcome to this episode of Chekomukhi. Now, in this episode, if you remember, last episode we spoke about Artemis and all the things that are happening to that. And therefore, in reference to that, there's a very important issue which we all need to address, and that is the issue of space radiation. So basically, what happens is in space, there's a lot of radiation, which is the invisible danger facing astronauts. So when we imagine space travel, we think, oh, wow, it's so good. You have these astronauts, futuristic spacecraft. But the problem is that it's not just the thing of the lack of oxygen, but the bigger hazard in space is that there is radiation, which cannot be seen or heard, but it's an invisible threat. So what exactly is space radiation? So radiation is basically energy traveling through space in the form of particles or waves. Now, on Earth, we are exposed to small amounts of natural radiation every day from rocks, sunlight, even food. But fortunately, since the Earth has a magnetic field, its atmosphere as well as the magnetic field together act like a giant shield, okay, which actually protects us from harmful radiation coming from space. So, what is the kind of radiation? You can see this image. Here is the Earth, here's the moon, and you can see what we actually have. We have this magnetospheric, magnetopause around the Earth, but then we have the Van Allen belts. We have solar radiation, which is coming on to us. You have even galactic cosmic radiation, and all these are going to be important effects when we are even talking about moving to Mars. One of the biggest risks which comes from this radiation is through about cancer, leukemia, right? So what happens is that these various cosmic radiations which are there, they can actually lead to leukemia. So what are the different kinds of sources? The first source is galactic cosmic rays. So we know that in the galaxy there are high energy particles that originate outside our solar system, and many of them are produced by exploding stars like supernovae, and they travel across the galaxy at nearly the speed of light. And they are extremely energetic. They penetrate spacecraft walls, even human tissue. And some of them consist of heavy atomic nuclei such as ions, which can cause severe biological damage. The other source is solar radiation, the sun itself. Now, the sun actually has a solar wind, which is basically nothing but charged particles thrown from the sun. Now, occasionally the sun, once in a while, you know that the sun is a variable source. So once in a while, you also have solar flares and coronal mass ejections. And during these events, you have even more number of energetic particles which are blasted into space. Now, these astronauts are exposed to this radiation, and a powerful solar storm during a deep space mission could actually be life-threatening if astronauts are not properly shielded. The other important source which we have is we know that the Earth's magnetic field, what it basically does, it traps charged particles. And this creates regions which are called the Van Allen belts, right? But spacecraft, when they're traveling through these belts, they experience elevated radiation levels. So even when you have astronauts on the International Space Station, they receive some protection because they orbit relatively close to Earth, right? Space station is barely 400 kilometers above it. But the problem is if you're having a mission to the moon or Mars, etc., then you actually need to worry about it. Now, why is this radiation dangerous? Like I said, it's basically ionizing atoms, okay? And therefore, what happens is they basically attack our living cells, and they can actually damage the DNA and various essential biological molecules which exist, right? And human bodies are remarkably resilient, but prolonged exposure can lead to health problems. Like I also told you, you could even have a cancer risk because radiation can damage DNA inside cells, causing the likelihood of that you may have mutations which would cause cancer. And this is typically when you have long duration, if there are long duration Mars missions, for example, then you would get a lot more radiation than you do on Earth. There's also an effect which happens to the brain and the nervous system because of the high energy cosmic rays. And we know that it could impair your memory, learning, as well as decision making. So therefore, for astronauts which are traveling millions of kilometers from the Earth, maintaining mental performance is also critical, and therefore if you have issues like this, we need to be concerned about it. You could also have issues with the heart and cardiovascular problems essentially because with the gravitational force, you do not have the gravitational force there, and therefore what happens is the pumping the heart has to do is different, and that can lead to a lot of stress onto the heart. And in general, what happens for us is that the earth actually protects us. Like I mentioned earlier, we have the atmosphere, and then we also have the magnetic field. So if you actually see it, it kind of, if you have the sun even, throwing winds on it, you have this region over here, which is actually stopping these charged particles from coming in, right? So you only have them coming in from the poles, which are northern lights, for example. So what happens is you have the earth, which has its radiation belts, and these actually prove as very good shields, which protect life. So in the case of Mars, what happens is Mars is a very thin atmosphere, and it lacks a global magnetic field. And similarly with the moon also, you do not have an atmosphere, and therefore if we are considering moon or Mars missions, we obviously need to consider about the radiation. So spacecrafts, they actually we built it in such a way that there are this thing. Now here is a picture you can see of the radiation which you have on Mars. So you can see that there are certain regions where there's a risk of very high cosmic ray environment, right? You can see there's a large amount of this. Now the shielding materials, they provide some protection, but they are not equally effective, and therefore there are hydrogen materials such as polyethylene, water, etc. And thick metal shielding can also provide this thing. We also need to have what are called storm shelters. Specifically, the storm we are referring to as solar storms, and underground habitats also. So on the moon or Mars, astronauts may also build habitats underground or cover them with soil and rock, and this thing. So if you typically see an image over here of the radiation doses, these are all on the ground you're fine as you go up, but then even if you go to the International Space Station and then you go to higher ones, the amount of radiation doses which you're going to be exposed to are much larger. And therefore, if you're thinking about, we are now thinking about traveling to Mars, we do need to give this very important this thing. So NASA's Curiosity rover, which is on Mars, it measured radiation levels and confirmed that deep space exposure is a major concern, and therefore people are working on actually how to this thing. One option is to send robots instead of sending humans, which is something which is being followed, especially by the Chinese. They're more on sending robots than humans, but we need to try to solve this problem by using lightweight shielding materials, as well as some scientists also propose generating artificial magnetic fields to deflect charged particles, and you need to have medical countermeasures, as well as we need to have very good space weather forecasting so that well in advance we know whether there's going to be a solar storm, etc. So as humanity now prepares to return to the moon and eventually to Mars, understanding space radiation is become very important. It's not just it is a challenge which we need to actually address, and humans, while we continue with our exploration of the stars, we need to find a solution to this problem, and that is something very important. So let's hope we do manage. Thank you.